Hello, I'm the Code Architect. Today, we're demystifying LLMs, from tokens to text generation. Let's dive in.
You've probably wondered how a machine can take a simple prompt and just write a complex story, or a chunk of code, or even a poem. I mean, it really feels like magic, doesn't it? But it's not. Today, we're going to pull back the curtain on large language models, or LLMs, and show you exactly how they turn a few of your words into some pretty incredible text. Let's dive in. Yeah, at first, the whole thing can seem like a magic trick. But like any great illusion, it all comes down to understanding the method behind it. And in this explainer, we're going to break that method down piece by piece so you can see exactly how the impossible actually becomes possible. So here's our roadmap for today. We're going to start with how words get turned into numbers. Then we'll peek inside the thinking machine. After that, we'll see how it creates brand new language, how the model learns in the first place. And then finally, we'll zoom out for the big picture. Okay, so our journey starts with a really basic challenge. Computers don't speak English. They don't speak any human language. They speak math. So the very first thing we have to do is translate our words into a language of numbers that the machine can actually work with. This whole translation process starts with something called tokens. An LLM takes every sentence you give it and smashes it into smaller chunks. These could be whole words or sometimes just parts of words. You can think of these tokens as like the individual Lego bricks or puzzle pieces the model uses to understand what you've said. Each one of those tokens then gets converted into a long list of numbers, and we call that an embedding. This is basically the word's mathematical ID card. This embedding gives a token a specific location on a huge, multidimensional map of language, which captures not just its meaning, but how it relates to every other word. This image here shows you exactly what I'm talking about. It's literally like giving every single word its own GPS coordinates. Words that mean similar things, like cats and dogs, they end up clustered really close together on the map. And words that are totally unrelated, they're miles apart. This map is the foundation for how the model gets context. All right, so we've successfully turned words into numbers. Now let's see what happens to them inside the core of the LLM, its neural network. Welcome to the engine room. Those numerical embeddings we just talked about are fed into this massive neural network. You can see the data flows through an embedding layer and then into a series of these transformer blocks. And these blocks are where all the heavy lifting happens, where the model really starts to figure out context and relationships. See, this network is built with a ton of layers, and each layer has a special job. One of the early layers might just be focused on grammar, figuring out the structure of the sentence. But a deeper layer is busy trying to understand the semantic relationships, what the words actually mean, and how the concepts connect. Now, one of the most brilliant parts of this whole thing is something called the attention mechanism. Think about it. When you read a sentence, you automatically focus on the most important words to get the meaning, right? Well, the attention mechanism does the exact same thing, giving scores to each word to figure out which ones are the most important for understanding the big picture. And here's what that looks like in action. The model is calculating these attention scores for every word, creating a weighted output that's totally aware of the context. This is how the model knows that when you say, the athlete sat by the riverbank, the word bank means the edge of a river and not a place you put money. So the model has processed our request and now has this deep, mathematical understanding of what we want. But a bunch of numbers isn't very useful to us, right? So now comes the really exciting part, turning all of that math back into words we can actually read. Now, the model could just play it safe. It could choose the single most probable next word every single time. But if it did that, the result would be so boring and repetitive. That's what we call a deterministic approach. To be creative, LLMs use a stochastic, or kind of random approach, which allows for way more varied and human-like answers. So instead of always picking the number one most likely next token, the model uses a technique called sampling. It looks at a whole range of pretty good options and then adds a little bit of randomness into its final choice. This right here is the secret sauce. It's what allows an LLM to generate text that's diverse, surprising, and sometimes genuinely creative. We've seen the whole process now, from words to numbers and all the way back again. But how does the model know what to do in the first place? Let's take a look at how these incredibly powerful machines actually learn. Well, the foundation is built by training the model on a just staggering amount of data. We're talking about massive libraries of books, articles, websites, and code from all over the internet.
By digesting all of this information, it starts to learn all the patterns, the grammar, and the really complex relationships that make up human language.
But what if you need the model to be an expert in something specific, like medical research or legal contracts? Well, that's where fine-tuning comes in. You take a general pre-trained model, that's our base chef model here, and you train it some more on a smaller, specialized set of data to create a specialist chef model.
And I love this analogy because it just makes so much sense. The base model already knows how to cook. It gets the fundamentals of language. Fine-tuning is just like teaching that amazing chef a whole new cuisine by giving them a bunch of specific recipes. It makes them an expert.
Okay, we have definitely been deep in the technical details. Let's zoom out now and take a look at where this technology is actually being used today and some of the really important things we need to keep in mind. You are almost certainly already interacting with LLMs pretty much every day. They're the brains behind sophisticated chatbots and virtual assistants. They help create and summarize articles, they can perform incredible language translation, and they can even write working computer code. But, and this is a big but, it is not all magic. The pros are huge, right? Boosting creativity, efficiency, automation, but there are some serious cons. These models can pick up biases from all that data they read, and they're famous for sometimes generating confidently wrong information, something people call hallucination. So, let's do a super quick recap of the entire journey. Step 1, we tokenize text into little pieces. Step 2, we create numerical embeddings to capture their meaning. Step 3, we process those embeddings in a neural network using attention. And step 4, we decode the result back into new, human-readable text. Simple as that. And that brings us to our final thought. We've basically cracked open the black box and demystified how these things work. The bigger question that's left isn't just how they work, but how we, as the people who build and use them, should guide what they learn going forward. What does the responsible path look like?
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.